Alright, I know that these new equations can be a little intimidating when you first look at them, and so I'm going to walk you through some example problems. This will show you hopefully how to read the problems associated with the equations and also how to actually plug them into your calculator. So the first one I'm going to look at is focal length. What is the focal length of a lens when an object placed at 27 centimeters produces an image at 42.1 centimeters? So the first thing that we need to do is look at the question and see what do we know and what are we looking for. So the object is placed at 27 centimeters. That is our object distance, or our DO. The image is then produced at 42.1 centimeters. So image, we know it's going to be an I, and it's produced at that place, so that's our image distance, or our DI. And it says right here in the question, what is the focal length? So we know we're looking for focal length. So you've got an F, a DO, and a DI. Which equation would you use? That's going to be this one right here. 1 over F equals 1 over DO plus 1 over DI. And again, I know that the reciprocals particularly can be a little intimidating. It is really easy to make a mistake when you're working with these, and so that's why I wanted to show you how to plug it into your calculator properly. So the first thing that you want to do is just plug in your information. Okay? We know that we're looking for focal length, so I don't have to rearrange my equation at all. 1 over F is going to be equal to 1 over 27 centimeters plus 1 over 42.1 centimeters. And you can do 1 over 27 plus 1 over 42.1, but you're not finished with that yet. Your final answer is going to then be the reciprocal of that answer. You also may be tempted to just flip the whole thing over and say F is equal to 27 plus 42.1, but that's not correct either. So here is the way that you actually will plug it into your calculator. Okay, so we're going to say that F is equal to, and here's what you're going to plug in. 1 divided by, open 2 sets of parentheses. That is very important. You must open 2 sets of parentheses in order for your calculator to understand. So 1 divided by 2 sets of parentheses open, 1 divided by 27, close the first set, plus, open another one, 1 divided by 42.1, and then you can close both sets of parentheses. So what that's doing is it's keeping this fraction together, 1 divided by 27. It's keeping this fraction together, 1 divided by 42.1. It's then adding those 2 pieces, and then the set of parentheses on the outside is taking 1 over that whole thing. So that's why the parentheses are really, really important. When you plug that all into your calculator, you should get 16.5 centimeters. And I want you to practice plugging that into your calculator and make sure that that's what you get. If you get a different answer besides something that rounds correctly to 16.5, then something is off somewhere and you need to ask for help. Okay, but this is how you're going to plug it in to your calculator. Next one, object distance. A lens with a focal length of 18.9 centimeters produces an image at negative 12.3 centimeters. So we know that the image is on the other side, the same side of the lens as the actual object itself. Okay, we call that behind the lens. So we're going to find our givens. Focal length is 18.9 centimeters, that's our F. Produces an image at negative 12.3, that's our DI. Okay, and we're looking for DO. So we're going to start with our same equation. 1 over F equals 1 over DO plus 1 over DI. I want to get DO by itself. So in order to do that, I need to move my 1 over DI to the other side of my equal sign. Well, it's added here, So if I subtract it from both sides and do 1 over f minus 1 over di, that's going to be equal to 1 over do. So again, I'm going to plug in what I know. 1 over 18.9 centimeters, that's my focal length, that's my 1 over f, minus, that's important, 1 over negative 12.3. Just because you've already got a negative here doesn't mean you suddenly don't subtract, okay? Adding, subtracting, multiplying, dividing, you're going to do that no matter what your numbers are. Sometimes they might be negative, sometimes they might be positive. You just have to be really, really careful when you're typing things in. So again, to put it in your calculator, DO is going to be equal to 1 divided by, open 2 sets of parentheses. 1 divided by 18.9, close one set, minus, open another set, 1 divided by negative 12.3, close both sets. That's going to keep everything separate so your calculator understands. When you plug all of that in, you should get 7.5 centimeters. Again, practice that, plug it into your calculator. If you're not getting 7.5, then something is going wrong and you need to ask for some help. So what this is telling us is when we place our object at 7.5 centimeters, which is closer than f, closer than our focal length, we're going to get a virtual image. Now remember, virtual images are produced behind the lens. That's our negative image distance. And now we're looking for image distance. An object is placed 22.7 centimeters away from a lens with a focal length of 13.5 centimeters. Where is the image produced? Okay, object is placed 22.7 centimeters. That's our DO, our object distance. A focal length of 13.5 centimeters. That's our F. Where is the image produced? We're looking for DI. Same equation. We're actually going to rearrange it the same way we did before, only now we're subtracting the 1 over DO to move it to the other side. So 1 over DI is going to be equal to 1 over F minus 1 over DO. So plug in what you know. 1 over F. F is our focal length, 13.5 centimeters, minus 1 over 22.7. That's our object distance. When you plug it in your calculator, 1 divided by, open 2 sets of parentheses, 1 divided by 13.5, close the set, minus, open a new set, 1 divided by 22.7, close both sets of parentheses, hit equals, and you should get 33.3 centimeters. Now we're going to look at our other equation, the magnification equation. And this one confuses people sometimes because it's got 2 equal signs in it. We're going to talk about that in just a moment. What is the magnification of a lens when an object placed at 32 centimeters produces an image at negative 14 centimeters? So the first thing that we're going to do is to, again, look at our givens. The object is placed at 32 centimeters, that's our DO. The image is produced at negative 14 centimeters, that's our DI, and we're looking for magnification. So the only equation you have for magnification is this one, M equals HI over HO equals negative DI over DO. When you've got 2 equal signs in the equation, basically that means that all 3 of these things are equal to each other. If you have all of them, I suppose you could use all of them, but you don't need all of them. So what we have here is a DI and a DO, and we're looking for magnification, which means we don't need this center piece. It's okay if we don't have our image height and object height because they're not necessary. We've got 1 piece on the left side of the equal sign and 1 piece on the right side of the equal sign. And that's really all we need. So we're left with M is equal to negative DI over DO. So now you just plug in what you have. A magnification, or M, is equal to negative of negative 14 centimeters. This is very important. always include the negative on your DI. If you've already got a negative DI, then you're switching the sign. If you've got a positive DI, you're still switching the sign. So don't leave that part out. It's very important. So negative of negative 14 divided by 32, when you plug that into your calculator, you should get 0.44. A magnification doesn't have any units on it because it's just a how much bigger, how much smaller. So the magnification of this lens is 0.44. Let's look at one where we're finding image height. This has a lot more variables in it, so again, you have to be very careful of what you have and what you're looking for. A 20 centimeter tall coffee cup is placed 16 centimeters away from a convex lens, and an image is produced at 48 centimeters. How tall is the image? So let's look at what we have. A 20 centimeter tall coffee cup. The coffee cup is our object. It's telling us how tall it is. That's height. So this is our object height, or HO. It's placed 16 centimeters away, so that's our object distance, DO. The image is produced at 48 centimeters. That's our image distance, or DI. How tall is the image? Okay, tall is height, so we're looking for HI, height of the image. And again, we've got the same equation, M equals HI over HO equals negative DI over negative DO. Or over DO, excuse me. Well, we don't have magnification, but we don't need it, remember. You just need two pieces. One piece on the left side of the equal sign and one piece on the right side of the equal sign. So we can ignore that M, and we're left with this piece, HI over HO equals negative DI over DO. And the first thing that you're going to do is plug in what you have. Okay, you're looking for HI, so we leave that alone. We know that HO, the object height, is 20 centimeters. We know that our DI, our image distance, is 48 centimeters, so it's negative 48 centimeters, divided by DO, which is 16 centimeters. Now you're going to cross multiply, and we get HI times 16 centimeters is equal to 20 centimeters times negative 48 centimeters. You're going to then divide by 16 to get HI by itself. Okay, 20 times negative 48 divided by 16. Plug all that into your calculator and you should end up with negative 60 centimeters. Try that on your calculator, plug it in, make sure that's what you get. If you have questions, ask. Next, object height. The coffee cup is placed 17 centimeters away from a convex lens with a focal length of 10 centimeters. A negative 18.6 centimeter tall image is produced at 24.3 centimeters. How tall is the coffee cup? Let's see what we've got. Placed 17 centimeters away. We know that we're putting our cup 17 centimeters away. That's our DO, our object distance. Focal length, 10 centimeters. That's an F. Negative 18.6 centimeter tall image. That's our image height. And we know that image is produced at 24.3 centimeters. That's our image distance, DI. How tall is the coffee cup? We're looking for HO. Well, the only equation that we have to find HO is this one right here. And remember, we don't need the magnification. And notice that there's no focal length anywhere in this equation. So let's look and make sure we have all the other pieces. We know we're looking for HO. We've got an HI, an image height. We've got a DI, an image distance. We've got a DO, an object distance, which means we just don't need that focal length. It's okay. It's just extra information. So plug in what you know. HI is negative 18.6. We're looking for HO. Negative DI, negative 24.3 over DO, which is 17. Cross multiply again. HO times negative 24.3 is equal to negative 18.6 times 17. We're going to divide by this negative 24.3 to get HO by itself. Plug all that into your calculator. Be really careful about your negatives. and you should get 13.0 centimeters, or it should round to 13.0. If you don't get this exact answer, 13.0, when you round it, double check yourself. Did you put in all your negative signs? Did you hit equals when you needed to? Okay, if you're not sure, ask for help. So that's it. Come back and look at this video. If you need additional help while you're taking the quiz, make sure you ask for help if you have any questions.